Today, we're going to continue with our goal of being able to master solving systems of equations by substitution. However, today we have one slight added step in that now if you look at the system that we have here in front of us for letter A, there is none that's already solved for x or for y. So what we're going to do is we're going to start off by doing step one, which is to look for the variable that is alone. And what we mean by that is that it has no coefficient. You also probably want to try to stick to ones that tend to be positive. So if I look here, I see that we have an x alone. So what we're going to do then is we're going to solve for it. So we're going to take our 2x, or sorry, not 2x, my bad, my 2y equal to x plus 1, and I'm going to solve it for x. I'm going to subtract 1, and I know we're used to solving for y, but we don't always have to solve for y. So now that I've got 2y minus 1 equals x. So then step 3 is going to be to follow those steps for substitution. So if you recall from yesterday, that means we are going to box in the 2y minus 1 since we just solved for it, and that's what x is equal to. So then I'm going to box in the x as well. Then I'm going to go ahead and substitute in there. So I have negative 2 times x, which we know is equal to 2y minus 1, minus y equal to 7. So then I can go ahead and solve this problem. I started off by distributing that negative 2, which gives me negative 4y plus 2 minus y equal to 7. And then I get I have a negative 4y minus y, which is negative 5y plus 2 equal to 7. Bring that up over here. And we get that we have negative 5y. We subtract 2 to get negative 5y equals 5. Divided by negative 5, please don't forget your negatives, giving me y is equal to negative 1. Then I'll go back up and put that in here, which gives us, if I change my colors, we will have 2 times y, which is negative 1, minus 1 is equal to x. 2 times negative 1 is negative 2. Negative 2 minus 1 is going to be negative 3 equal to x, which means that our ordered pair solution is going to be negative 3, and y was equal to negative 1, so there is my ordered pair. Then as always, our final step is going to be to check. I am not going to show the check, but I do expect when I check your notes that I will see a check. Let's take a look at the next example here we've got. We have x minus 9y equal to negative 10, and 6x plus y equal to negative 5. As I mentioned earlier, you tend to want to stick to the ones that are positive. In this case, we have 2 of them, so I'll let you take your pick. Being that we typically solve for y and we solved for x the last time, I'm going to go with this equation. So I'm going to take my 6x plus y equal to negative 5, and I'm going to subtract 6x from both sides. Putting that into standard form, I get y is equal to negative 6x minus 5. So go ahead and I will box that in since we just solved for it. And I'm going to box in the y in the other equation. Then when I put it in there, I get x minus 9y, and y is equal to negative 6x minus 5, and that is equal to negative 10. So we go ahead and we can distribute that 9. So we have x minus 9 minus 6, which is plus 54x. Minus 9 minus 5 is plus 45, equal to negative 10. And 5x plus 54x is 55x plus 45 equals negative 10. minus 45 on both sides, which gives me 55x equal to negative 55. Divide both sides by 55. I bet you thought we were going to get a big answer, giving me x is equal to negative 1. Then I take that negative 1, and I'm going to put it back into my original equation, giving me 6 times x, which is negative 1, plus y equals to negative 5. 6 times negative 1 is negative 6, plus y equal to negative 5. Add 6 to both sides, giving me y is equal to 1, which means my ordered pair solution that you will need to check before you move on is going to be negative 1, 1.